the team I was working with that developed Rosette ESS, that's sort of why I became really convinced of the mobile process calculi even before looking at it as a programming model. We were analyzing what's called relaxed transaction processing, where you let go of the one or more of the acid properties. So the acid properties are atomicity, consistency, isolation, and durability. Those properties were identified by Jim Gray, a Turing Award winner who did work in database theory. So in relaxed transaction processing, you relax those in order to be able to have a wider range of data access. A really good example is, imagine that you're booking a trip and you want to simultaneously get your car, your airfare, and your hotel, and those are coming from 3 different data sources or 3 different data suppliers. And you kind of don't want to do your trip if you only get 2 of those, right? So you'll do the trip if you get the flights in the hotel, or if you get the flights in the car, but you got to have the flight and you got to do 2 of them, right? So that's not the same as, 2-phase commit, where you need everybody to commit in order to commit the transaction. So that gives you a sense of the sense of what's meant by relaxed transaction processing and why it's practical and important in today's world. And the Elliott-Moss style nested transactions are not a sort of a panacea or a one-size-fits-all solution. So they're really a range of different transactional semantics. The closer you get to ACID, the more you are locking up resources, which means that the database is unavailable, which means everything slows down. And the more you relax the ACID properties, the more you can run into issues with staleness of data and other kinds of consistency issues. And so you can't have a one-size-fits-all model, but what you can do is you can have building blocks that allow you to build transactional semantics that best suit your application domain. And that's what the mobile process calculi allow you to do in the transactional database side of things. So Rolang gives you a set of building blocks to build transactional semantics, and you build those on top of a high-performance database. So something that has a query mechanism and gives you building blocks for transactional semantics, and that's what we mean by the RSpace together with Rolang solution gives us.
Thank you.
Yeah.
I got you, Greg. So just one question before we start the tech update. So when you say it's a database, are you storing terabytes of data in RSpace?
We can do. Ideally.
Okay. So when we say a high performance database, like
what you really want to do is you want to do tiered storage, right? So just like in RSong, you don't want to pull. There's no high performance app these days that doesn't do tiering of the data. So there's immediate cache, there's sort of working storage, and then there's long-term storage. And this is the same whether you're talking about large scale things like Netflix, or whether you scale it down to the hardware model, right? So hardware has a cache, hardware has memory, and hardware has disk, right? It's the same design pattern that's iterated at different scales within the system. Does that make sense?
Yeah, it makes perfect sense.
Yeah, cool. All right. Well, we have a lot to get through today. I would love to begin with the technical update because we have some exciting stuff to get through.
Thanks, Greg. Hi, everyone. We are going to start with a technical update, and then I'm going to introduce you to Joe Denman, who's going to do a demo for us. But let's go through the update page first. And so I'm putting a link here in the window. This is what the page I'm going to share. And now I'm going to share my screen. Okay. All All right, so here we are, community update number 68. We have started a 2-week sprint that ends April 29th, where our priorities are the following. We need to finish fixing Casper tests for cost accounting to go in. I'll talk more explicitly about that in a few minutes. We're going to complete the conversion to the updated RSpace. I'll also speak to that. Launch of testnet 2, and work on Casper to support slashing. Those are our goals in this current sprint. We do plan to release our node 9.3 this week, and you can see what's going on in that in the release plan. As always, you're welcome to take a look at what we're working towards in the Mercury launch. Testnet is live and has, celebrate with me, community. We have had Testnet live since last Thursday, and not only has it been live, but we also haven't had to shoot any of our validators in the head and bring them back up. This is huge. It means that we're not experiencing out of memory errors. We're not experiencing problems with node functionality as validators on what is proving to be a fairly, a somewhat busy network. And it's just really good news. It's a nice milestone to cross over, and I hope you can join me in being as excited about that as I am, and certainly recognize the importance of that. I do have a node running right now, and if we take a look at the I'm looking at the public testnet. I'm looking at node 3, which is a validator. And you can see we're looking at block 1451. And we have no we as a development team are not doing any proposing on this network. This is related to blocks that the community is producing. And that's also been really good to see. So many thanks to our community members for participating on PubNet. Kudos to the SRE team for getting us to a place where, we've got a lot of stability in the validators that we're running. And also kudos to the team for improving the stability for us to get to this point. Just really, really excited about that. I'd like to speak a little bit about our public testnet plan related to testnet 2. And so I'm going to turn over to, the link is here. It's the public testnet information page. You can link to it directly from the wiki. And if you do that, you'll find all kinds of information about the status of testnet and things that are happening. But I want to speak explicitly to our plan because it has changed as of today. We had initially planned to release testnet 2 this week, and we have run into some fairly significant blockers and understand what those blockers are. Work is in place to address those blockers, but at the moment it prevents us from releasing testnet 2 as planned. We also, just given the timing of the calendar, we are facing the Easter holiday. We've got members of our team taking some time off around the Easter holiday, also just related to our team has been working very hard since Christmas, and it's time for some of them to take a break. So we're anticipating some time off from people next week. So we anticipate a later release of testnet 2, kind of thinking about May 6th, but I want to draw your attention to what is blocking testnet 2, and it's these 3 tickets. You're welcome to take a peek in JIRA. I am going to talk about them more explicitly in just a moment. When these tickets are addressed and when there's no other issues blocking, specifically bringing cost accounting into the project, being able to demonstrate a Genesis ceremony that includes rock balances coming from Ethereum, and the ability for users to claim their Genesis issued test rev, that is the point that we will release testnet 2. So that's my testnet update. Community testing, we do plan to hold a session tomorrow. That is at 1400 UTC. We hoping, and a little blocked right now based on some problems in Drone, but our plan right now is to cut the release of our node 9.3 and update testnet 1 with that, so that we can have our community testers help test and validate some fixes related to some bugs that we've been seeing in testnet 1. So that's the plan, to work with 9.3 on the public testnet tomorrow, working towards that and having to overcome a bit of an issue in our CI system right now in order to make that a reality. But at this point, I'm pretty optimistic that that's going to be a reality. So that's our plan. All right, more specifically, in consensus, the bugs that we are working on are all things that we have observed in the public testnet. So kudos to our public testnet users for helping to reveal these to us, and that the work is either in progress and this one actually is just done since I wrote this report an hour ago. So that is good news. We plan to demonstrate tomorrow, if we can get 9.3 in testnet, that this ignorable equivocation issue is no longer a mostly just a bothersome log message. It doesn't break testnet. It's just annoying, really. And then we do have a PR open to fix the invalid repeat deploy, also observed in testnet. That is very much in progress. Kent is working on that. He's also been out of office a fair amount this week, so work is slower there than it would be typically. We are also working to investigate a failure to receive a Genesis block. This is a real problem on testnet right now, and for community members to grab that Genesis block very soon after bringing up a node. We do have 2 PRs in that really just support debugging. At this point, we don't have enough information to help us debug this issue in Casper. So the 2 PRs that have been merged into dev, and that will be in 9.3, will support the debugging, and then we should be able to attack this issue once we have more information on what's causing it. So that's the work of consensus. Cost accounting, we are continuing work to update the Casper test suite and the system contracts. A lot of this I talked about at length last week, so I'm not going to rehash that, but just suffice to say, cost accounting is working. It's working outside of the project. In order to bring it into the project, it must pass our integration tests and play nicely with all the other code that we expect to work on the platform. That is our current blocker. You can read more about that if you select the JIRA ticket 3135. You can see the other work that's related to this and that is blocking the completion of this ticket and the completion of this work by bringing all of cost accounting into the code base. I'm looking forward to you guys being able to see Joe demo how cost accounting functionality works. Again, it's not fully in the project, but he does have the ability to demonstrate how it works in our code and in tests. A lot of work has gone into our node this week, specifically related to peering. And if you're a testnet user, if you're a node user, you have attempted to join a busy network, you've experienced this pain where sometimes it is difficult to get enough peers or get peers quickly. The work that has gone into node since we spoke last week serves to address this. And specifically, I will call out RChain 3152 and RChain 3159. We are very much looking forward to giving this a go in testnet as soon as we cut 9.3, because I think it will we'll see some improvements in blockers that people have observed with peering in testnet. So kudos to Sebastian and Pavel for getting that work in. Our space team, Lukash and Dom have been working very diligently and very fast to get the long-term fix completed. And the long-term fix is a renovation of our space to better support the needs of Casper. And so at this time, that development work is complete. It is working outside of the project. They are working now to bring it into the project. Obviously, it needs to pass our integration tests and there are a couple PRs out that still need to be reviewed, but that is very much work in progress and is going very nicely. Once they finish once that work goes into the project, we're going to operate our space in parallel, meaning that our space as it exists today will continue to operate by default. There will be a flag that you can use to look at the renovated R space, and then as we observe the renovation working the way that we expect it to, and as we debug anything that comes up, we will then make the renovated R space the default. So that's kind of the process. If you're running off of dev today and expecting to see R space renovation work, it's not there yet. It will be there first via a flag, and then later by becoming default once we're confident in its functionality and like how it's behaving. And then after that, there are some small steps, much smaller than the renovation of our space, but similar. We'll need to take some similar steps to bring changes into replay, and that's what the team is planning for at this point. Our SRE team is working to complete our testnet dashboard, and that is going well. Obviously, they are doing a tremendous effort in supporting the public testnet. We did have some CI issues pop up that we're trying to address, and that's an emergency situation. When CI stops serving the team, it is all hands on deck to fix that, because it blocks everybody and it blocks everything going into the code base. So that is what Tomasz is working on today. Rev issuance. I want to make sure that I speak to this very explicitly. one of the requirements of testnet 2 is a demonstration of the ability to issue test rev based on rock balances held on Ethereum. That's well documented on the Rev issuance page on the developer website, and you can read more about it there. But in short, we're doing some work to update. There is an existing script. It's in GitHub. You're welcome to go take a look at it. It needs to be updated. It no longer works the way that it used to. And to successfully pull those rock balances off of Ethereum. So that is work that Tomasz is working on. We also previously pointed to, I believe it was an Infura node to capture these balances. The plan has always been to stand up, for the cooperative to stand up an Ethereum node to look to it to provide those rock addresses. That work is also in progress. And then we are testing the Genesis ceremony with the inclusion of rock balances in that Genesis block. So all of these things are kind of in flight this week. We've run into a bug that Pavel is helping to investigate related to the Genesis ceremony. Funny thing, it works in testing in our integration test. We take it for a walk in the wild and it doesn't do exactly what we would like it to do. So we're investigating that bug. Finally, with the completion of the, I'm pivoting to the wallet. With the completion of the wallet implementation, I spoke last week about some hardening work. We did have an issue, and that is RChain 3203. You're welcome to take a look at that issue and the risk that it puts on the platform, and as well as the plan that we have to address it. We have kudos to the team and to Greg for working very quickly and to get focused and to come up with a plan to address this issue related to the wallet, and then we will start implementing that work in the near term, but not immediately. It's not an emergency from a testnet standpoint, so we will pick it up in short order. I'll just pause there. Are there any questions about what I've talked about so far?
Well, Kelly, thank you for the update. I wanted to ask, I spoke with Kent on Monday, I think it was during the Casper stand-up, and he said that the repeat deploy he had caught. So I believe that there was a semaphore issue where they had a test on a semaphore, and then in the non-acquired branch, they were releasing anyway, unaware that release was actually allowing other threads to go through. So I think Kent reported that in the Casper stand-up as they know what the issue is and that they have a fix.
Okay, I haven't
so
seen it come into code. I haven't seen it come into the project yet, which is why it says in progress. Yeah, but
okay, yeah. So I think that he's going to get a pull request in shortly.
Okay, great.
Yeah, and then I also wanted to second your point. That I was really delighted about the way we worked on the wallet issue. In particular, it was very, very much by consensus, and we're starting to see stakeholders be able to come forward with all of the facts at their disposal and good design sensibility, so that it's not resident in any one person's head. And this was really nice. First of all, there was good substantive discussion around whether in fact it was even a bug, and it's subtle to view it as a bug, right? There were even programming languages designed that had the kind of scoping issue that what this amounts to as a feature. So dynamic scoping was considered to be a feature in certain implementations of Lisp. And over time, people began to see how that kind of scoping issue resulted in non-locality for debugging code, and which makes it horrendous to debug code. And the team sort of quickly, just in a few minutes, got to consensus on the fact that this kind of scoping makes it too hard to go and be secure about contracts, because you'd have to go through all the dependencies of every contract in order to check whether or not you had leaked authority into a scope wider than you intended. And then there was good substantive discussion around possible fixes with the right kind of sensibility and sensitivity to language design issues. So, and again, I felt the whole thing was done with good group, consensus group engagement which means that this is the sign for me of the health of the project. The project is not healthy if these kinds of questions always have to come down to one human being. But if we start to have a good community of stakeholders who are able to make these kinds of decisions and come to reasonably quick decisions on this point, then we have a functioning, healthy code base. So I was very encouraged by this particular process.
Thanks for that, Greg. Any other questions about the state of our development? Okay, well, I'm really pleased to welcome Joe Denman. He's one of our members of our core team, and to provide a demonstration of the work that's going into cost accounting, specifically related to the deployment of contracts that cost rev or cost flow, and the ability to account for that and deduct that as part of the project. So, Joe, can I turn it over to you?
You can.
Thank you.
Yes. So cost accounting, colloquially known. Cost accounting is a method to limit the amount of computation that any one agent can submit to the platform without incurring some sort of cost. So yeah, that's a problem because Whirling is Turing complete. So someone could issue a deployment with a contract that just runs forever, eating up minor resources. And it was actually Turing's idea the first time to limit computation, to meter it based on just integers, a well-founded set or something. But I think Ethereum popularized it in the blockchain space. So this cost accounting framework is similar to Ethereum's gas. And the portion that we are trying to check into the code base now is the portion that charges a proportional amount of gas from, or amount of rev from the deployer's associated vault. So this links Casper wallets and, well, quote, cost accounting. So I'm not doing this on Node yet. We haven't quite gotten that far. But this should do just to demonstrate the sort of behavior that we should expect out of the framework. Here I have a little test network set up. I guess I'll just go line by line on this. Yeah, so on line 39, we have a public key for our, that's supposed to represent the Genesis user, so it's a public key, but effectively like any other user. And yet another user, just in case we need the flexibility. A program that we're going to pull into a deployment. That deployment here, using that program. And then a set of terms that are deployed in the Genesis block. So these are built-in terms. You can think of them kind of like libraries, although some serve, are pretty crucial to the operation of the platform. For example, this is the Casper contract. This, on the other hand, is just a contract that's a collection of operations on lists, although necessary. On negative number is a contract guaranteeing that a number that we're trying to deduct never goes negative. Make mint is the contract that mints rev and controls access to purses. Again, the proof of stake contract here. Auth key is an authorization sort of interface for object capabilities. Rev vault here. This is the contract that allows users the sort of higher level interface, the direct interface between vaults, so where they store their rev exactly. Rev generator here, we just need this to actually create the initial vaults. And you'll see here that we're starting with one vault for our user. So this is a user's public key. And the initial balance of that user is balance. which we defined above as the maximum possible value that is an integer. So what I'm going to do here is go through a couple of different scenarios. Let me... So to start out, let's actually, let me tell you a little bit more about how the pricing works. So in order to represent cost in an execution environment in an efficient way, we have this idea of a flow price, and flow is equivalent to Ethereum's gas on RChain. And the flow price is the amount of flow, I believe, per rev, times flow. No, it's the number of rev that each unit flow costs. And this is just going to be multiplied effectively by the cost of the program to determine the equivalent amount in rev that the program has to cost. So the point is that a user should run a program. We should measure how complex it is, and then they should be charged for that complexity. So let's try deploying this tiny little program, which just sends the integer 2 on the quoted channel, or the quoted process 1. We're going to deploy this program, initializing the balance of our user to the highest possible value. We're going to make them rich. The flow limit is, again, the highest possible value that you could choose, which effectively means that since each flow represents like a small little step of computation, a flow limit that is a maximum value represents a computation that doesn't terminate anytime soon. And then, of course, the flow price, we're saying that each unit of gas causes, or flow costs us 0 rev. So this is a free computation that potentially runs for a long period of time. And we're doing this just so I can demonstrate how much this guy would cost in terms of flow. I think SBT may have fallen asleep. No.
There you go.
Ooh. Okay. So all these print statements are different points in the execution of our tiny little program here. Let's just go through these and see what is going on. The first thing that we'll see, that we'll notice is that the Genesis vault is being instantiated. Genesis vault, obviously the vault that is endowed with the full quantity of rev in the Genesis block. So we're instantiating that vault. We're transferring a certain amount of rev from the Genesis vault to the user vault. So it starts in the Genesis and it ends up in this user's vault, corresponding vault. We are then instantiating user vault. And this is, I guess, a point that Artur brought up a couple weeks ago about how we get this cool ability. Well, I guess it's just a result of the sort of the compositionality of Whining, which is that since we write programs out of concurrency primitives almost exclusively, and concurrency, is useful for expressing things that are order independent. When we write a bunch of small contracts in terms of concurrent primitives, our larger contracts also exhibit the same sort of order independent behavior. So I can transfer to a user, for example, before that user even has a vault, and that's valid behavior on the platform. The next thing that happens is that the proof of stake contract is instantiated. We finish that instantiation. And the obvious question, I guess, would be when a user pays for a contract, where does it go? Their payment goes into the proof of stake contract, and that all those payments that are collected are eventually distributed among the validators, which is part of the validator rewards program that we're working on. So these represent effectively all of the contracts that we need to transact. After we have those, we're going to start evaluating our contract. And during evaluation, we'll notice the first thing that happens is that we compute the user's balance. And the reason that we're going to do this is, I guess, actually just because of rate limiting's intention, which is to prevent against resource attacks. So the first thing that we're going to do is check the user's balance. If the user does not have enough rev in their vault to cover the maximum case, the maximum potential cost of the program, then the deployment is rejected outright. In this case, the maximum cost of the program is equal to flow price times flow limit, which is equal to 0. Which means that, of course, we do have enough rev in our vault because we have all the rev at this point. So now that our balance is sufficient to cover the cost of the computation, we see a few internal operations that happen just to get the vaults in line. So the first meaning that we have to find the contract that effectively gives us access to vaults. That's the vault, rev vault instance. Then we have to find the user's vault. And then once we've successfully found the user's vault, we can query for the user's balance, which again is a max value. We then determine how much we're going to have to pay for the deploy. And as I mentioned above, the amount that actually no, this is something else. Yeah. So since a contract may not use all of the flow that it purchases, we have to do something with the remainder. We can't just pocket it. So the remaining flow that's not used in the execution is refunded back to the user, meaning that the amount that we see here is going to be the actual cost of the program. In this case, no matter how long the program runs, it's always going to be 0. Then we call into the proof of stake contract to pay it. We finish paying it, and then we finish evaluating the contract. And what we want to determine now is that after running the contract, we see the balance of the deployer reduced by the corresponding cost of their contract. And in this case, that's 0. So in this case, the user balance shouldn't change, and it doesn't. Any questions so far? Cool. Now let's do something that is a little bit more realistic. And I actually don't remember how much this one costs, so we'll have to see. But based on, just based on these numbers, we, a small contract like this and a large balance like that, where each flow costs just 1 rev, we should certainly not see any sort of errors due to running out of flow. Although I'll show you one of those next. So. implicit numeric widening. Oh, sorry. Okay, so let's look at this again. As we saw before, we have our Genesis contracts above, our contract evaluation here, and it looks like the user's balance is correctly computed to be 500, while the contract itself is computed at 33 rev. So that is actually 33 flow times 1 rev per flow. So what we should see is that 5,500 is deducted by 33 when we pay for the contract, and that is what we see. So the question, I guess there's still a question of what happens what happens to a program if the program runs out of flow, or if the program throws any sort of error for that matter. In that case, we still want to enforce rate limiting. So we still need to disincentivize sending programs that, for example, are just going to terminate. So we still charge the user for the amount of rev that is consumed up to the point that the contract throws the error. However, once the contract throws the error, all of its effects, aside from the payment, are reversed. So this one should be more expensive. I think that'll be enough, actually. So what I'm going to do here, so this bit of the contract is going to be pretty expensive. And I'm going to try to provide an amount of flow that is low enough to where this contract will run out. And when contracts run out of flow, they throw an error and they stop going. And then, yeah, we just charge what we can for the amount of flow that the user has purchased. So we should see an error and then more green. Okay. One test failed. That should be balanced. Well, let's see what's going on here. So yes, all the same stuff. We compute the user's balance to be 200, and then immediately it seems the computation runs out of flow, which is cause for terminating the contract, hence the red. So we continue. We start to pay for the deploy, and it looks like the contract actually accumulated 282 flow, and that's probably something to do with the size or atomicity of particular operations. If one operation costs much more than other operations in the language, then it's possible that you could throw an out of flow error for something that is higher and stop at something that's higher than the maximum that you set. And we can do all sorts of things to minimize those occurrences. So what we should see, yes, and actually, In this case, we're seeing that when we try to pay the proof of stake account, that we have insufficient funds. And this is actually not expected behavior. So I guess it's a good thing that we're seeing it now. The point being, I suppose, that and the reason I guess why this happened is because obviously we have a balance of 200 in our contract through or consume 282 flow, and 1 flow per rev is too little too late. Yeah. And so this one's kind of backwards. We'll certainly have to investigate that one. The insufficient funds error, however, is actually, I suppose, something else to demonstrate. Or did I already show that?
That's what you just demonstrated, Joe.
Well, yes,
No.
and that's what you were hoping. That's what you were hoping to demonstrate here, but we ran into the new issue, which is really cool.
Yeah. Got it. Yeah. Right. So let's see. Why don't we try something?
Well, it actually brings up an important point, which is that people need to be aware that when they're doing resource planning in the concurrency setting, there's lots and lots of non-determinism. So when you're doing this kind of planning, you have to consider max branches, min branches, and these kinds of things, as opposed to thinking that you're going to have a one-size-fits-all price, because it won't work. And it's literally the cost of doing business in the concurrency setting.
Yeah.
There's, I mean, one of the things that you pointed out at the beginning is there's some cool stuff in the sense that Rolang allows you to do dependency-based computing. So it's not that it's order insensitive. It's rather that you can park a computation waiting on a dependency. So when this dependency is satisfied or arrives at this channel, then we can continue the computation. And so you can do things in what appears to be an out of order fashion. In fact, it's not out of order. It's that you're enforcing the order by setting up chains of dependencies. And on the flip side of it is, of course, since things are coming in orders that are not necessarily determined, cost estimation becomes a little bit more subtle.
Yeah, and I suppose that the crux of the matter in the last example is that a couple things like you're saying, Greg. So concurrency issues are one. So that contract wasn't itself non-deterministic, but writing a sort of a rate limiting harness for concurrent language also we also have to consider some like issues around parallelism. So what we've seen before, and something that we're getting a good handle on, is that when one thread when one thread of the computation runs out of flow because locally out of a central reservoir of flow, then we have to make sure that all of the threads stop. And doing that simultaneously is I mean, it's tough. But yeah, you're right. There are things that we're looking into. I guess that's the demo. Next steps from here are to integrate the changes with Casper and with Node, which would, and after those integrations are made, then cost accounting is ready to be introduced into the platform.
Thank you very much. That was great.
Joe. Well done.
Really appreciate it. Yeah, absolutely.
I have a question about Flow. Will it have a trading pair like Neo does?
No. Flow is like gas. It's not a. It's not,
Neo has gas as well, but it's its own trading. It's a currency as well.
It's not its own token. It's not a token.
Okay, yeah.
So the Any questions for Joe, or any questions about cost accounting from the community? Awesome. I have to jump off very soon here, but I want to just mention that we'll be headed out to Barcelona to speak with investors. And then we'll be headed out to Shanghai to speak with investors. I've been speaking with a lot of the Chinese community, and we would love to do some face-to-face RChain China community meetings, because we do have some time out in China. So been working with some folks to help organize that. And we're really looking forward to the engagement with investors, and there'll be more on that. We will do the closed door sessions on Friday to give more details on what's going on there, and we're quite excited about that. But I can't really talk about the details on this call. And so with that, I don't have any other updates to give. Are there any questions from the community? Awesome. Silence is golden. Thank you, Kelly and the team. This is great work. I'm really looking forward to seeing the update on testnet, and yeah, this is very, very encouraging. And good week to everyone, and looking forward to seeing you guys next week.